Hey friends, today we're going to do the first round of the Road to Las Vegas 2026. One of the first videos of the year I'll be doing. This is how to win the Microsoft Excel World Championship by Diarmuid Early, the champ himself. So we're going to do it again, trying to go with no lambdas, no macros. I don't know if I can do it in 30 minutes. It's a tough one. Let's see. Ready, set, go. So here we're doing a lookup on this level 1 table. Let's just name that P equals X lookup. Player name, returning the player description. And this is a very clever way to do the bonuses, where they kind of get unlocked as you solve the different levels. Which player has the longest description? So the longest description is just using length. And we can sort that manually to get Michael Diarmuid. Alright, level 2. I'm not going to read it this time. I messed up in reading it when doing this live. But ultimately what they want is a product of the middle digits of these numbers. So we will let T be split based on comma space. And then we'll say product concat, no, not concat, product value mid t length of t plus 1 divided by 2. There we go. Not controversial at all if you read the instructions very carefully. Okay, level 3. So you have, this kind of reminds me of sommelier. You have skill ratings and case ratings, and we have to compare these. So we'll name this cases, and we'll name this players. Let's see what we can do. Okay. So for a given player, so to look up a player's preferences, we'll say look up that in player number, return players, and then I'll drop the first column. So drop 1. Now let's subtract all of these. So we'll get drop these cases 2 columns minus that. So it should give us an array. It's transposed just to make sure I don't have any errors. Okay, that's looking okay. Now, if it's, let's see, let's t that. If t is greater than 0, then take t, otherwise 0. This is just a way of doing like a by-call max. And then what we'll do is by row sum. Okay, so that's all the values. And now I just want to say sort by. What are we going to go? This is cases. Case name, sort by that, -1. There we go. Okay. Speed. Which case has the most challenging for the largest number of players? Okay, so we just want to map this as a function. So we'll say lambda player, and then change this to player. Right? So now if we map that, take this lambda, go back upstairs. So we're going to take at group by of let's t be map. We're going to map all the players, right? So that's player number. We're gonna map all the player numbers using the lambda. Close that map, so that's T. So then, actually this group by can be inside the let. So at group by T count A 0 0 -2. That okay. Next, extract the unique letter in common between each consecutive pair of strings. Okay, so we'll let the words be split. What's the delimiter? Is a space / space. Now we're going to map. Basically, to get consecutive words together, we're going to map drop words 1 and drop words -1 XY. So, what are we going to do? We want to search for. Okay, so we'll say at filter. We're gonna decatenate X. So we'll say mid X length, sequence length of X. And then let's copy that part. So that's the decatenated X. And we want to find where it exists in Y. So is number finds will work for us. Y is number filter. Okay, so what does that get us? That gets us the one letter. And it has to be then each letter. So then we'll just concatenate that. Example. Great. Okay. Tough. The 6 most common letters across all the strings. Okay, so we need all the strings. So we'll say concat level 4 inputs. Level 4 is here. So that's all the concat. Now let's substitute out the spaces and the /. Okay, so that's just our letters. Let's T be that. Then we'll decatenate it. So decatenate T. It's going to be sequence length T1. Okay, so what are we doing with the decatenated letters? 6 most common in order from most to least. Okay. So we're gonna say concat take group by letters count A. We're taking 6. There we go, strong. I like it. Okay. This guy is a beast. You have to do it kind of step by step. I found it's a lot easier when you do it kind of step by step. I'll do it in a let, so it will be a single cell formula, but we'll go very kind of methodically here. So I'll let RNG be indirect. This is level 5 and this range. Then we'll say, let's see, what do we want to do? Array. So one of the things I want to point out is that it could either be top to bottom, bottom to top, left to right, or right to left. I always, in order to avoid having to do this nested forest of ifs, I want to get it into a state where I can just do top to bottom first and left to right second. So my logic here is, if I find top, if is number find top in this, I don't care the order, if it's top to bottom or bottom to top. If I find that, then give me the range. Otherwise, transpose the range, and I'll be able to handle that as if it was top to bottom when I do my sorting. Okay? So that's my array, ARR. Then close out the if. Okay, so far so good. Now I want to do the first level of sort. Now that I know I'm going top to bottom and then left to right, no matter the situation here, what I need to do is see, do I want to sort, do I need to sort it or reverse it? That's all I need to find out. So I'm going to put here top to bottom and then say equals, this either has to be top to bottom or, use the OR function, or this has to be left to right. That will indicate my sort order. So that's top to bottom, true or false. Left to right then will be the same logic, only we're searching this cell. So that equals top to bottom, or that equals left to right. And I'm using anchors here to preserve those. Okay, so now we're going to do our first level sort. So first sort equals sort by, we're going to sort the array by the sequence of how many rows in the array. And then this is the logic. So if if we're going top to bottom, then sort it normal, otherwise reverse it with a -1. And that, we're not, this is top to bottom, so that doesn't do it. But if I go over here, I don't know the original order, so I'm not sure if that's working or not, but I think that's work. I think it looks good. So now the second sort, going left to right, is going to be sort by the first sort, sorting by sequence of columns in array, and then the same thing, but it's if left to right, then we'll go 1, otherwise -1. Second sort. Okay, so far so good. The last bit is now, do we need to alternate or not? So I will say concat final answer if this equals no, then just return the second sort. We don't need to do anything else. If we do alternate, then what do we need to do? We're going to go by row with a sequence of the number of rows. So that's rows array lambda s. So what we'll do is for each row we'll say sort by choose rows of the second sort. And what are we going to sort it by? We're going to sort it by sequence. Yeah, it's going to be a sequence, columns, ARR. And then if S is odd, then we'll sort it like normal. Otherwise, reverse it. So that's going to go row by row. And the by row right here, we have to concatenate these results unless you're using a lambdafied version of by row that will allow you to do stack arrays. Okay, so something went wrong on this one. That's unfortunate. This one looks good. I don't know where the error is though. Second sort went through alright. Results. It's probably my last step. Second sort. So that's working. So somewhere on that last step where the alternate is yes. It doesn't like this. So we're gonna have to debug. Let's see. By row, sequence rows ARR. We're closing out sequence, opening up by row. So we have S as our value here. So choose rows, second sort. We're going to sort by sequence columns are. It should be if. If is odd. Then return result. Okay, now this is strange. We're getting 4 characters here. I'm expecting like 16 or whatever. I think we're having this array of array problems there. Add that at and it seems to work. Whew. That is a tough one. That's a very tough one. Okay. There's no bonus for that, so now we're doing the wolves. Okay, so I'm going to do this also as a let. First step, since I don't have any arrows, nothing, I'm not carrying anything into this case, I need to get a unique list of all the directions that we can travel. So concatenate that, let t be this, we're going to say mid t sequence length t1. So that's all the arrows. Let's unique them. Let's sort and unique. Okay, so we have a unique list of directions to travel. Let's bring these up here. And yeah, let's call this arrow. Say vertical distance that we travel for each of these. 1, 1, 1, 0, negative 1. So horizontal distance 0, 1, 1, 1, 0, negative 1, negative 1, negative 1. So we'll make this a table called D for directions. And now we'll get started. So equals let start cell is indirect of where the monkey starts. So start row is going to be row of start cell. That should be a comma. Start call is going to be column start cell. And okay, now we can map out. So our row, as we take each step, no, we need the arrows. Arrows is going to be mid this sequence length. So that's your arrows. Your delta of the vertical that you'll take with each step is x look up the arrows into our table that we made. And then horizontal distance is x look up arrows, returning h. Okay, and now we can model the rows and columns. So R is going to be scan, starting at our start row, feeding it dv, and summing those. C is going to be the same thing, scan, start call, dh, sum, and let's just check and make sure our output looks realistic, and so far so good. Okay, now we need to do the wolves. So the wolves are at these addresses. Text split. So wolves are looking good. Now we'll make a lambda called catches at turn. So given a wolf address, how many turns will it take for the wolf to catch up? So we'll do a very similar kind of basic start. So start cell is indirect of wolf. Start row is going to be row of start cell. And because this is in a innerlet, we're not running into any naming problems here. We can name these the same thing, and we'll use the innermost value for the let variable. Start call is going to be column start cell, and okay. Now we want to model the wolf row. So the wolf row is going to be a scan. We're going to start at our start row, and we're going to feed it all of the monkey rows, which is R, lambda A V, and then say we're going to be A plus the sign. We can take one step, so it's going to be the sign of V minus A. Alright, and then the wolf column is going to be something almost identical. Start call. We're going to pass it C, lambda AV, A plus sign, V minus A. Okay, now we've got the wolf rows, the wolf columns. What do we want to feed as the answer? It is going to be where row equals the wolf row and column equals the wolf column. So it'll be x match 1 WR equals R times WC equals C. Close the x match, close the let, close the lambda, and so that's a function that we've defined. Now, when does Lana get caught? Caught at, it's going to be the minimum of map all the wolves using catches at turn, like so. And that should be a number, 3. Okay, so Lana gets caught after 3 turns, and then the final thing that we have to return is the address. So index R at caught at, and index C caught at, like so, E7. Alright, now when I paste down, I got an NA error, it doesn't work. The reason is because the number of arrows is not enough. If the wolves haven't caught them after, I don't know, it was 8 turns, then Lana just repeats this set of moves. So we may need to repeat that a bunch of times. So up here, right before arrows, I'll put repeats, and I'll just give it a value, constant value. And then here where we use the arrows, I'll say repeat function twice here. Okay, and so with 5 now works, and actually most of these work, but up here we're getting into an error, so I'll change that to 10. And then over here we need even more. Let's change that to 50, and that works. Okay, so now the bonus key is Lana. And the question is, let's make it even bigger. Okay, so we're doing the same problem, only on a bigger scale. So we're starting in DLQ 4485. Here are Lana's moves, and the wolf positions are here. And if we've done everything right, we should be able to just take our formula and increase the repeat amount. If we increase the repeat amount enough, that should work, and sure enough it did. Oops. Dim port 321. Okay, I don't think I'm gonna finish. Well, actually, maybe I will. 5 minutes for level 7. So let's make this a table. And the goal here is to find out how many people beat Dim. So beat Dim, and that's going to be equals. This score is greater than. We'll filter scores where the rounds equals this round, and is number X match the players in this list, which is just Dim for now. So we have a list of people who beat Dim. Let's filter that. So I say filter player names who beat Dim. Calgare. Here maybe. Okay, so Dim didn't play in this round. So on this filter, put false. Okay. So these are the people that beat Dim initially. Who are the people that beat that list? So I'll take this. I'm gonna filter names this time. Filter T player. T in all these. Okay. So the round logic still has to stay. This T is going to change. Copy and paste values here. So now we're referencing this list. So that's the list of players that Sean beat in the last chance qualifier. Okay, so sort. No, I don't want to sort it. Let's make this unique. And actually, I probably didn't need that unique, but it doesn't matter. Let's just text join with a comma. Something seems off with that. Yeah, something's off for sure. We didn't check if they actually got a higher score. So times the score is greater than the score. There we go. And then instead of false, we'll just put blank. Very good. And then here, yeah, for now that's fine. So now when we get to our player, we're going to say equals filter. What's that name? So beat. So equals filter T beat on T player equals that. Okay. So now we can get several people in there. So we're going to join extra comma. Okay, and we'll get a split. Let's make this, I don't know if it matters. Now we'll make it unique. Sort. Text before. And finally, join again. To get our answer. Good. And greatest. Okay, a transferable champion is any player who beat the champion, who beat the champion. Okay, so we're not going to finish this in time, but we'll give it a shot anyways. So here we're just gonna expand this kind of iteratively. So right now the filter, let's say filter names on length of this. So in the next round, unique. $58 people, but we can keep going after that. So I'm going to make a copy of this formula, copy paste values, and then point this column at this instead. That makes the list longer, so we're now at 71 out of 72. I doubt we're stopping there, so copy and paste that, and now point this over here. And now our final list is, I think this was the, 48, it went down. I must have messed something up. Let's see. What did I mess up? We have our long list. How? Oh, look at this. What happened? These didn't, okay. These didn't get anchored. 72. Alright, final answer, 72. I think there's a lesson in there. Everyone has beat someone who has beat someone who has beat the champion. Any of us could have done it on any given day. So good luck to everybody, keep trying. We'll see you next time. I'm Excel Gladiator, and my goal in making these videos is to help people level up their Excel skills, as well as to grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment below, or check out one of these other videos.